My name is Kalpesh. I work for Ceph RGW team, the Rados Gateway team, basically at IBM. So today I would be going through the topic leveraging Ceph Rados Gateway for scalable and resilient object storage. So this is going to be the agenda for today. We will be going through the Ceph intro, what Ceph object storage is about, the key characteristics of RGW, the RGW key components, the use cases, the feature example, another use case, and the scalability of RGW and what we are going to do next. So let's start with Ceph. So Ceph basically is, everyone knows, majority of you know that it's an open source thing. So yeah, it's a distributed universal storage, software defined storage solution, and we do offer a single efficient unified storage platform for three types of storage basically. So it's an object, block and file, all three. So that's all about Ceph. We would go, for next we would be going through we would be focusing on what Ceph object storage is about. So it's a completely robust, scalable and widely deployed S3 endpoint which delivers low latency and high performance for it's for the enterprise object storage, right? And we are having a complete subset of Amazon S3 and IAM dialect. So and it's obviously it's security compliant as we support encryption, STS, then public access blocks, MFA deletes, IAMs, and policy IAM policies. Basically, it's for bucket, user, sessions, or roles, right? So that was overall about Ceph RGW. So these are some of the key characteristics of RGW, right? So it's basically you can scale it. It's scalable and growth potential. So you can scale it to petabyte and exabyte levels. So by scaling horizontally, it means you can add more and more servers with no single point of failure, right? So and it also has distributed architecture, no central controllers, and all nodes cooperate to manage the storage pools. So and to ensure the data redundancy and availability, we do support automatic, we do have automatic data placements and replication. So and for elastic growth, you can add storage nodes without any downtime. So and so let's go next to the cost efficiency and optimization. So we do just for avoiding over provisioning, we have a pay-as-you-grow model. So we do support that thing. So other than that, you can utilize the hot, warm, and cold tiers for cost savings. So you can just have the commodity hardware, which reduces the overall management and energy cost, which can overall reduce the total cost of ownerships. So next we have is accessibility and API integration. So we are S3 API compatible and RESTful APIs are compatible. So other than that, we have multi-region replication, which ensures consistent user experience. Yeah, going to next is high availability and durability. So replication and erasure coding protect against local hardware failures. So that's mainly for the data redundancy, and multi-region replication ensures geo-resilience. So it is just for the data disaster recovery. So and we do have archive zones, so which is the read-only or immutable replicated zone. We'll just talk about that in the coming slides. And as I discussed, we do support security. We are having security and compliance. So we do have bucket policies, role-based policies, IAMs, and STS. And the metadata and the lifecycle management, It enables advanced search and analytics, automate data retention, archival and deletion for lifecycle policies, and archive and retrieve data from the cloud or S3 tape endpoints. It's for the policy-based archival. And yeah, lastly, the operational efficiency and fast deployments due to user-friendly UI. So these are some of the key components of RGW. So first one, let's go for D3N. D3N stands for data center data delivery network. So it accelerates the data access for large data sets by utilizing a local caching layer, just like RAM or NVMe at the edge. This positions frequently accessed data closer to the Rados Gateway, significantly improving the performance. And this is a benefit Ceph offers for analytical workloads. So next we have is multi-site, then we have bucket notifications, then we have STS or IAM, and the last one is the standalone RGW. So bucket notification is the key feature that enables users to receive notifications about various events like within the object storage environment, such as the object addition, deletion, or modification to any of the objects, any of the event that is happening within the object storage environment. So this is I'll just go through this one. Yeah. So let's say you are having two zones, zone 1 and zone 2. There are two RGWs over there, two RGWs over here. At least one RGW is needed in any of the zone. So there is a multi-site async replication that happens between the two zones. Like these zones are like the data that's on the zone 1 gets replicated to the data on the zone 2, and similarly simultaneously for the zone 2 as well, right? So the global load balancer just is for the HA. So that's the whole idea of multi-site replication. So other than that, now we would come to the archive zones. So like replication and erasure coding mechanisms. Sorry. Replication and erasure coding mechanisms do offer excellent protection against hardware or zone failures. However, these techniques aren't backup. So in single zone, object storage users protect their data by enabling versioning and the multi-factor authentication delete. So to their buckets. So but in multiple zones, enabling feature in like each zone would consume more capacity and performance than necessary. So what we can achieve through this archive zone feature is like reduce the number of copies, reduce the number of S3 copies or object copies, I mean. So the versions, by copies I mean the versions. So of across all the zones within the zone group by enabling versioning exclusively for the archive zones. So rather than in each zone. So this would safeguard our data, and the automatic versioning would just like every time a user comes in, like a user object comes in, it's updated, it's getting updated. So archive zone automatically creates a new version of it, and this eliminates the need for scheduled backups and ensures the changes are captured like promptly. So other than that, another example or another benefit of using archive zones is near real-time resilience. So by continuously capturing data updates, archive zones provide near real-time data resilience. So you may be confident that all of your data modifications are protected within the archive zones. And yeah, other than this, So we have the capability to utilize both the multi-site bucket granularity and this archive zone feature, which is granting us precise control over each of the bucket within each of the bucket or individual zones, individual objects within our storage environment. So this gives us the flexibility to empower us to selectively choose the data that deserves the additive protection to the archive zones, right? So yeah. So yeah, this was majorly about that one, the archive zones and the multi-site async replication. So let's go through the object, like Ceph object bucket notification. So this is an example we have for like an X-ray pneumonia detection event-driven pipeline. So let's say some X-ray is getting in, getting uploaded into the S3 bucket. So the object gets, like, the creation of an object creates a notification with the topic name storage to the event. So like this, the second part goes for like it creates a notification based on the topic storage, and this would again go through the next part, and the event is created which needs to we need to analyze that image, like the image that has been uploaded, just for that event get created, and then we just go for the function named detect pneumonia plus anonymize the the image. So it would just retrieve that image right from the bucket, and then the function, this function would just analyze would do all the work, and it would just save the pneumonia risk detection into the, like, if it's pneumonia, then it would be saving it in the another bucket, and if it's not, then the anonymized image would be saved into another one. So yeah, that's a bucket notification example. So now this let's say you are having so this is another example. So let's say you are having an e-commerce platform. So maybe it could be a physical store as well and an online store as well. So you just ingest your data. So this is an example of AI or AI or ML data lakes. So you are having an e-commerce. You just ingest your data pipeline into the Ceph cluster. So Ceph cluster over here is working as the intake, like this whole thing right here is for the Ceph, like it's for the Ceph object storage. So you can, your data comes in, your data is landed into this landing zone right over here. As we discussed in the bucket notification example, if any object comes into the bucket, bucket notification gets created, notification gets created in the Kafka, and based on the security classification. So what security classification does over here is, let's say you are having like all of the data that comes into the CSV files, so the browser data that comes in. So that would be just coming in with some of the IPs, right? The logs would be having some of the IPs. So most that S3 select would just filter out all those IPs, and based on the filtering out of those IPs, it would just create two separate buckets, one for the malicious one and other one for the which are the saved or better ones, right? So based on those things, this under two buckets, the logs basically gets created. So you get that's so data comes from the landing zone and it goes via this process to the to the raw zone. So now from the raw zone, your data, let's say you are having we are having two, you can have any two query engines, just like Spark or Presto. So your data goes into that. So that what Spark and Presto does is the data enrichment for the browser logs, and let's say you are also having e-commerce transactions, you would feed into the staging zone, and the staging zone would, so both of those data would go into the query engines, and the data enrichment would happen over there, and you would be having the iceberg tables in the parquet format inside the curated zone. So now in the curated zone, the data in the parquet format would be available for the consumption. Sorry. So yeah, would be available for the consumption. So now you would be like any of the user or like for the consumption. Let's say someone wants the data for their business intelligence, or like let's say some reports or anything. You can just have those things right from the, like you can fetch the data from the curated zone and do your work. So yeah, this is the ingest high level workflow. So let's say you are having a browser log shipping. So all of the logs that are coming in would go into the landing zone. The landing zone would create a S3 notification trigger job, would be going through the serverless job. So it would just the S3 select filter, S3 select would filter out the malicious IPs, and it would just feed in the saved cleansed log to the raw zone bucket, and the raw zone bucket would then create a S3 notification trigger Spark job, which would be going into the Spark job, and the data cleansing and transformation of the data gets happened over there, and the saved results goes to the staging zone buckets. So that was the ingest high level workflow. So yeah, let's talk about some RGW scalability. So like billions of objects in a single cluster, then GBs of bandwidth per node, dynamic sharding of bucket indexing. So what bucket indexing is, I'll just tell. So bucket indexing allows users and applications to efficiently remember the contents of an object bucket. So imagine a bucket as a directory in a file system. A bucket index acts like a list of all the files inside that directory. So that's what bucket index is about. So dynamic sharding of the bucket indexes, erasure coding and compression, hierarchical data placements, and lifecycle transition to colder storage classes. Sorry. So yeah, this is something about horizontal scaling and performance. So as you can see the concurrent threads, the total concurrent threads through the throughput. So yeah, what's coming in more? So D4, so for the tentacle release and beyond, we are planning to have D4N caching, then bucket logging, per bucket, per user usage metrics, deduplication prototype, distributed RGW standalone, and external bucket indexing. We'll go through some basic details about all these things. So yeah, D4N. D4N stands for Data Center Data Delivery Distributive Network. So it would be an intelligent and distributed cache. It will have a capability of read-write on a distributive network, and which would obviously increase the overall performance. So bucket logging, it provides a mechanism for logging all access to a bucket, enabling granular auditing and monitoring of all bucket level activities, enhancing the security and operational visibility. Per bucket and per user usage metrics. So we plan on enhancing Ceph Rados Gateway by introducing custom usage counters to monitor specific metrics such as total request, byte sent, and byte received. Currently, we are tracking quota details at account level. With this feature in place, we will be able to get the quota details at per bucket and per user level. So deduplication prototype. In the context of S3 objects, currently all objects are uniquely stored. So we plan to identify identical objects stored multiple times and replace them with the references to a single unique copy. So like benefit of that would be the space optimization and cost efficiency. So seamlessly integrating with existing S3 APIs and workflows. Next would be distributed RGW standalone. So RGW standalone means RGW on top of a local POSIX file system and running it without any other part of the Ceph. So we are already supporting RGW standalone and working on making it scalable for distributive network as well. So through this we are just trying to make RGW as a direct service for ones who are having their own S3. So other than that, what's next is external bucket indexing. So RGW uses primary indexing for managing object metadata, where each bucket has an index that stores information about the object it contains to make Ceph RGW bucket indexing more efficient, leveraging external bucket indexing such as B plus trees or other optimized data structures can significantly enhance the performance and scalability. We can achieve this the faster lookups and introduce query operations. So yeah, that's it. Yeah.
When you do multi-site replication, how do you make sure that the
Sorry, you're not audible.
When you do multi-site replication, how do you make sure that you track the objects that are on one side and the other? Because it's asynchronous.
Yeah.
How do you know you're actually in sync? What performance metrics can you check? And how can you see which bucket might be giving issues?
I'll get back to you with that answer because one of my colleagues is over there and she works for the multi-site async, exactly what your question is. She can address to that one.
So we have many monitoring mechanisms for multi-site. So using UI, which is Ceph dashboards, you can check the bucket stats. So there is a option in the UI where you can enable UI for both of your sites or cluster. And with CLI, there are many options like bucket stats. You can count the number of objects which are there in the site. And if you have enabled granular bucket sync, in that case also you can check the bucket stats on both the sites. If the number of objects is same, that means it is consistent. The other way you can use other than bucket stats is listing, which is anyways an expensive operation, but bucket stats is the correct operation that you can use. And you can also, as he has mentioned, you can also use performance counters wherein you can check the number of objects using Prometheus. You can check the number of objects in both the dashboards. You can get it through the APIs.
Thank you.
Yeah, please.
Yeah, when we have millions of objects, in case also of multi-site, but regarding purely the bucket and as a shard, the more shard we have, it looks listing objects take a while.
Okay.
So how you think you will it will improve it and may fix it by having the metadata outside?
Okay, that's a good question. So basically, I'm not the one who is working on that particular part. But I'll surely address your question. I'll let you know outside. If Vidushi, you can answer that one.
Is it on the listing performance?
Yeah.
So in Tentacle there is also a feature which is coming, which is which will be basically improvement on the index sharding.
Mm-hmm.
So it will twice like when the sharding is happening. So it will generally we see that there is the block time is there.
Mm-hmm.
So since you can reshard dynamically to a very high number, you can set that. So while the bucket is resharded, you will see better listing performance for. So you're talking about the high volume buckets. Yeah. So you definitely will see that there will be an improvement in for the listing for those like properly optimally sharded buckets.
Yeah, please.
Are there plans for improved integration with OpenStack Keystone of Rados Gateway?
I don't know of any right now, but yeah, could be in the future.
Are there any specific use case you are looking for?
Yeah, if you are looking for any specific use case, and maybe I can just address it to the team.
Yeah, so it would be great if it would be possible to have multiple key pairs per OpenStack project that cannot all access each other's buckets.
Okay.
So because right now you can create multiple key pairs per project, and then each key pair can create a bucket, but there is no way to separate these buckets between the key pairs.
Okay. Sure.
Which can be a security issue, obviously.
Oh yes, that's correct. Yeah, I'll surely address that to the team.
Yeah, thank you so much.
Yeah, please.
And the archive zone needs like a multi-site setup, right? It's not the same as this.
You can have for a single site as well or the multi-site as well.
Okay, but it's not the same as this archive sim module, right? Where you do like the external S3 archiving kind of thing.
Oh yeah, you can do that. But for let's say you are having a single site. So single site would also support an archive zone. So there would be one active zone that would be.
So it's both on the same
Yeah,
site.
exactly. Yes.
And for external stuff, I think in the beginning you mentioned some policy.
Yeah, policy based. You mean yeah. So like that would the archive zone would be having the admin access. So you would be needing an admin user based policy or something like that to just to like delete or like let's say one object is getting created in the active zone, and then it would obviously get replicated in the archive zone. But let's in the production zone, the object gets deleted. Then inside the archive zone, it would still the replication would be still there, and it would just have all the information about that particular object till any like anyone having the admin access, like through the user policies or through the bucket policy, you're having the access, and they'll just delete from the archive zone as well. So you will need that access to delete from the archive zone as well.
Mm-hmm.
Yeah, please.
Question, you mentioned big improvements in accounting, user requests, quotas, and so on. Do you have any plans to improve accounting of Turing case when which data goes to like cold or hot storage class? Because as far as I know, for now there is no way to determine which amount of data goes there or all.
Okay. Sure, I'll get your question.
It is in plan.
Yeah, it is actually in the plan. So I'll get your question and I'll surely address it right here. Yeah, please.
Okay, for tentacle release, yes?
Oh yeah.
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 Cool.
So send.